transforming quadratic functions. Alright, so our only vocab today is parent function, and that's basically the starting function, the most basic form of either a linear, quadratic, or a different type of function. Okay? So the parent function for a quadratic is going to be this one. Okay? F of x or y equals x squared. Okay? That's our parent function. That's the one that starts everything else off. Okay? And we can look at all of our other functions as a transformation from our parent function. So for this one, f of x equals x squared plus 5. You can see our parabola right here. That is the same as f of x equals x squared, our green parabola, except it's been shifted up 5 units. Okay, and that's where this plus 5 is. That's what that plus 5 is doing. Okay, f of x equals negative x squared. Well, that's the same as this one, except it's been flipped. It's been reflected over the x-axis, and now it's opening downwards. Okay, f of x equals 1/5 x squared. Well, that's the same as this one, except it's wider. It's been expanded. Okay. And our last one, f of x equals x squared minus 2x. Well, that's the same as our parent function, except it's been moved over and down a little bit. Okay? So we can think of all of these functions as just transformations or changes to our parent function, and that sometimes makes it easier to easier to figure out things about them. Okay? So our first concept is comparing the widths of our parabolas. And remember, our standard form for quadratics is y equals ax squared plus bx plus c. And the part of this equation that determines the width of our parabola is a. It's the coefficient of x squared. Okay, whatever number you have next to x squared, that's going to determine the width of your parabola. All right, and it's important to note that it's the absolute value of a. Okay, the width does not change by whether a is positive or negative. Okay, the greater the value, the wider it's going to. The narrower it's going to be. But if it's a really large negative number, it's still going to be very narrow. It's just going to be pointing down instead of up. Okay? So we can see right here we have our parent function. Okay? And then here we have 2x squared. All right, we have y equals 2x squared or f of x equals 2x squared. There's not a lot of difference, but if we use f of x, that is guaranteeing that that value is a function. Okay? So if I was going to graph y equals or f of x equals 2x squared, it'd look much the same as this one, except instead of being this wide, it would be about this wide. Okay? It'd just be a narrower graph. And yes, it is just about cut in half. Okay? That's because every time I put in a value of x, I'm going to be multiplying the result by 2 for this one, meaning my y is going to be twice as big. It's going to be twice as tall. So every time when I get to 1, okay, it's going to be 2 times where it is on my green graph, or it should be if my graphs are accurate. All right? And the next one we have is any equation with a very small, the absolute value of a very small coefficient, is going to have a wide graph. Okay, whereas this one made y larger, it increased y so that we had a really tall, narrow graph. This one is going to make y smaller, meaning we're going to have a wider graph. and I shouldn't say tall or short because all of these graphs will keep going to infinity. So they're all the same height, they all have the same vertex, but this blue one, this one with a smaller coefficient of a, is going to be wider. Okay. When you are looking at these, you can think about the distance from 1. All right, the greater distance you have away from 1 when it's larger than 1, when the absolute value is larger than 1, the narrower your graph is going to be. Okay, 2x squared was this narrow. If I had 5x squared, it'd be even narrower. If I had 1,000,000 x squared, it'd be super narrow. Okay, if it's less than 1, it's going to be wider. And as you approach 0, the smaller and smaller and smaller and smaller value of your a, the wider it's going to get. If this is 1/2, if I had 1/3, it would be out to here. If I had 1/10, it would, I wouldn't be able to see my arrows on this line. It would be somewhere out like that. Okay, so the closer you get to 0, the wider your graph gets.